All right, guys, so today we're going to take a look at number 8 on the Lewis dot structure homework. And we're going to follow the rules for drawing a Lewis dot structure. Now, this one's a little bit different because this molecule has a charge. If you look at the formula carefully, it should look pretty familiar. That is the sulfate ion. Now, a sulfate ion, just like any polyatomic ion, is just a molecule with a charge. In this case, it has a charge of -2. So how do we deal with that when we're drawing a Lewis dot structure? Well, what we need to do is follow the same rules. We're going to add up all of the valence electrons for this molecule. And so if I look up sulfur, it has 6. There are 4 oxygens. Each of them has 6 valence electrons. But since this has a charge of -2, that means we have an extra 2 electrons in this molecule that we have to account for. So you're going to adjust the total number of valence electrons based on charge. If the molecule has a negative charge, you're going to add that many electrons. Again, because a negative charge means that we have gained electrons. If there's a positive charge on the molecule, you're going to subtract that many or take that many electrons away from the total. In this case, we have a -2 charge, so we're going to add 2 to our total. And so 5 times 6 is 30, so this is going to be 32. Divide by 2, and we have 16 pairs of electrons that we need to place around this molecule. So if I go ahead and start doing that, I'm going to put the least electronegative element in the middle. Another way to think about that is usually your singleton goes in the middle, and so I have a single sulfur that's going to go in there. When I'm trying to decide which one is the least electronegative, I look to see which one is further from fluorine. Oxygen is right next to fluorine on the periodic table, so I'm not going to put that one in the middle. Instead, sulfur is 1 period down, and so that's going to be the element that I put in the middle. But again, you can look at it, and if there's a single element, that's probably the one that goes in the middle. So my single sulfur in the middle, 4 oxygens around. I'm just going to place them around like this. And then I need to start connecting them. So 1, 2, 3, 4 pairs of electrons are going to be used to make single bonds from each oxygen to the sulfur. So I subtract 4, and that gives me 12 left. So then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So all 12 pairs of electrons are used to complete the octet of those terminal oxygens. So we're done. Everything has a full octet. Everything is bonded to the sulfur. We're good here. Because this molecule has a charge, just like when we were drawing the Lewis dot structures for ions, I need to indicate that it has a charge by placing it in brackets. So the whole molecule goes inside of a set of brackets, and then I'm going to put that charge on the outside of the brackets. So we use the same rules for drawing covalent compounds. We just adjust the number of electrons based on the charge. We adjust the total number of valence electrons based on the charge. And then we draw our Lewis dot structure the same way we normally would. And then at the end, you need to put brackets around it and then put that charge on the outside.